Now, what is inverse of a matrix? Before we understand the inverse of a matrix, we have the matrix A, and there exists a matrix B, that the product of the two is coming is I. So the product of two matrices, if it's an INT matrix, then this particular matrix B is called inverse of A. That is B equal to A inverse. Other way, that is A into A inverse result is I here. Now, we discuss here what is A inverse. A inverse is equals to 1 upon value of determinant into adjoint of A. This. Now I take a matrix A which is 2, 0, 3, 1. Then I have to check whether this particular matrix is invertible or not. So for the invertibility of matrices, we have to just work on the determinant of this. Because if the value of determinant comes out to be 0, the inverse does not exist. So I found the determinant of this. What is determinant of A? It's 2 minus, that is 0. Answer is 2, which is not equal to 0. So that means the value of determinant is not 0. So matrix A is invertible. We already have discussed one thing. When the determinant value is not equal to 0, does it a singular matrix or non-singular matrix? The matrix should be non-singular. So it's a non-singular matrix, so it's invertible. Now let's work on this inverse. For finding inverse, we should know the adjoint of A. Now, for adjoint of A, what is definition of adjoint of A? It is the transpose of cofactor matrix. Sign I have already put. Find the particular cofactors for all of this. What is cofactor for this? Row deleted, column deleted 1. For this it is 3. For it is 0. For it is the 2. Take the transpose of this. What transpose comes out to be? 1 minus 3, 0, and of course the 2 here. So what is A inverse equals to? By this formula, it is 1 upon value of determinant, that is the 2, and 1, 0, minus 3, 2. Generally, we keep the value of determinant outside only. Don't try to divide it because it makes our calculation difficult. Now, so what is A equals to? 1, 0, minus 1, 2, minus 1, 0, 1, 3, 1. What is inverse says? A inverse is equals to is what? 1 upon value of determinant into adjoint of A. What I should find first? Should I find adjoint of A first or should I find the value of determinant first? I should find value of determinant first to check whether the matrix is invertible or not. Means its determinant answer should not be 0. That is, it should be non-singular matrix. So what is value of determinant A? Let's check 1 into this value of determinant. How we find? We just select any of the row, only one row, or any one of the column, and multiply the element of that particular row with their corresponding cofactors. So I have selected the first row. So element is 1, and what is cofactor of this? 1. I deleted first row, first column, elements are minus 1, 0, 3, 1. Then it is what? For this element, signs are plus, minus here. Element is 0, and what is the cofactor for this? Row deleted, column deleted, it's 2, 0, 1, 1. plus minus plus sign. So plus sign element is minus 1. What is cofactor for this? This row deleted, column also deleted, elements are 2 minus 1, 1, 3. So what's it? Minus 1 minus 0. 0 into something is going to be 0 itself. Minus 1 into what is it? 6 plus 1. The value is minus 1 minus 7. Answer is minus 8. Which is not equal to 0. Since determinant answer is not equal to 0, so we can find the inverse of this 3-order matrix. Now for finding the inverse, what we need? That is adjoint also. So how we find the adjoint of a matrix? It is the transpose of cofactor matrix. For finding the cofactor, would I put the determinant sign first? Or should I put plus minus sign also? Which is a must condition. That is, I should put signs here also. And put up a sign of transpose also. Because many times a student find all the 9 cofactors correctly, but forget to put the sign of transpose and whole calculation goes wrong there. So what you will do, you will find all the cofactors of them. You will take transpose of all these, and then what is going to be the A inverse of this? A inverse is equals to 1 upon value of determinant, which was minus 8, and the matrix which you obtain after taking the transpose of it. That will give you the inverse of a matrix which is of order 3 by 3. Now, A into B equals to, for example, C is given here. We have to find the matrix B. So it is not like your lower class maths, that is B equal to C upon A. What I have to do is, I have to remove this A from here. For removing A, what I have to do? I have to do multiplication by A inverse, so that there comes this IT matrix here. Now the multiplication which is done, that is before a matrix, is pre-multiplication, and which is done after a matrix, it is post-multiplication. So I need to multiply by A inverse here. I cannot multiply in between the two. So it is A inverse into AB equals to, what I do? A inverse on left or right? I did it here, pre-multiplication. So I'll do here also pre, A inverse into C. What is it? I into B equal to A inverse C. What is I into B? INT matrix multiplication with any of the matrix give the same matrix as answer, because I is taken as 1 of maths. So it is B equal to A inverse into C. That's it. Now, if someone asks you find a value of, that is A here. Since A I have to find, so I have to remove B here. So multiplied by A inverse or B inverse? Obviously B inverse. Does it pre-multiplication or post-multiplication? In between multiplication cannot be done, so I'll multiply by B inverse here. So this is A into B, it is post-multiplication B inverse here. See, here also post-multiplication B inverse. That's answer is I. So A into I is equal to C into B inverse. So what is I into A? That is A equal to C into B inverse. This is how we get the value of a matrix. Now, some relation if it is given, how to get inverse out of that, like it is here. A square plus 2A plus 3I is equals to 0, for example. Someone asks you find A inverse from here. But A inverse does not exist anywhere here. To get A inverse, I should multiply to each of the term by the A inverse. So what is it? A inverse into A squared plus 2 into A inverse into A plus 3 into A inverse into I equals to A inverse into 0. What is A inverse into A squared? Just like your powers, plus 2n minus 1, that forms here. A inverse into A, that's I. That's our definition says. A matrix multiplied by inverse always give you I in the matrix as answer. 3. A inverse into I. I is just like 1 of max, so it is a same A inverse equal to this is null matrix as answer. I have to get A3. So what is 3 A inverse is equals to? Transfer all these terms to the right side. What is it? 0 minus A minus 2I. So A inverse is going to be what? 1 by 3 within bracket minus A minus 2I. This is how we can get A inverse from here. That is what we did here. Now determinant got its big application in solving the system of linear equation. Now for solving the system of equation, we need to find the value of determinant which is formed by the coefficient of this. Like I take example, solve 2x minus y equals to minus 2, 3x plus 4y equals to 3. To solve it by the use of this determinant and rather with the matrix method, we forms the certain matrices. Let A matrix equals to the coefficient matrix. So it is 2, minus 1, 3, 4. Then variable matrix. The two variables x and y are involved, so it is x and y. And then a B matrix which is formed by the constants minus 2 and 3. Now the question may be raised that why I have formed here 2, minus 1 and 3, 4 in the order of the variables coefficients, and here I have formed a column matrix. The reason is simple, that is, if I write the variable in column form, then and only the multiplication of two matrices is possible. So what formation we got? A into x equals to B. You can try out. First row multiplied by first column, what is it? 2x minus y equals to minus 2. Similarly is for the second only. Now Ax equals to B. We have to find x matrix, that is the variable x and y. So what I have to do? I have to remove A from here. Obviously what I will do? I will do a pre-multiplication by A inverse on both sides. So what is pre-multiplication result? A inverse Ax equals to A inverse B. What is A into A inverse? It is I. What is I into x? It is x. So x equals to A inverse into B. So this result should be known to you. That is, the variable x and y we can find by the use of x equals to A inverse into B. Even these two should not be get interchanged. There is generally a blunder is committed. Now, we have to get A inverse, and for A inverse we require what? A inverse is equals to 1 upon value of determinant into adjoint of A. So there we require the determinant of A. Now this particular determinant's value decides the nature of the solution. Which nature of solution you have done in your class 10th? A system of equation may have unique solution, that is called consistent solution. The system of equation may have infinitely many solution. They may have rather no solution, which is called inconsistent solution. This all is decided on the basis of this particular flow chart which is here. First you evaluate the value of determinant A, and if determinant of A value is not coming equal to 0, the solution is unique. That means we will have a consistent solution. Now if determinant value is not equal to 0, then our problem rather has increased. If determinant answer is 0, find the value of adjoint of A into B first. If its answer is not equal to 0, there is no solution. But if adjoint of A into B's answer is 0, then we will have infinitely many solutions, and there is a way of doing it this separately. So I repeat, for consistent solution what we need, the determinant answer should not be 0 and we are going to have a unique solution. So first we'll work with the problem which are having a unique solution. Let's start. Now for this particular system of equation, what was it? I repeat, our A matrix was what? Formed by the coefficients, that is 2, minus 1, 3, 4. X was for your variable matrix, which is X and Y, and constants were, that is minus 2 and 3. What is the concept involved here is A into X equals to B. So what is X equals to? It is A inverse into B. I repeat again, you should not interchange. The inverse has to come first, then it is the B here. Now to get the A inverse, what do you all need? 1 upon value of determinant into adjoint of A. Now, what is value of determinant A? Product of left, that is 8, minus 3. See, I have kept them in the bracket because these two minuses may bring a different answer. So determinant value is 11, which is not equal to 0, so matrix is invertible. Now, adjoint of A. What is adjoint of A? It is transpose. This T sign should come first. Then the sign you put up, plus, minus, minus, plus. Let us find the coefficients for them. For this particular one, row related column, that is the 4. For this one, it's going to be 3. For this one, it is minus 1. And for this, it's going to be 2. So what is the adjoint of A? Take transpose of it. It's going to be 4, minus 3, 1 and 2. For 2 by 2 matrix, you can do a direct check also. That is, the check is what? These two elements interchange their positions. So it is 2, 4, now they have become 4, 2. And the sign of other diagonal changes. It was minus, so it becomes plus. It was plus, so it is minus. I again repeat, diagonal elements will interchange each other, and the sign of the other diagonal will change. Now, what is A inverse here? A inverse equals to 1 upon determinant value, that is 1 upon 11, and what is it? 4, 1, minus 3, 2. So we got A inverse finally. Now to get the value of X matrix, we have to use this particular formula. So what is your X matrix? XY equals to A inverse, that is 1 upon 11, 4, 1, minus 3, 2, into your B matrix. And what is B matrix? Minus 2 and 3. 1 over 11. Now it is multiplication of this two matrices. Best thing is we underline the first row and multiply by the element of columns of second matrix. So rows multiplication with the column. What is the answer? It's -8 and then it is the 3 here. For the next one, what is it? -3 into -2, that is 6, and plus 6. So it's going to be 1 over 11 minus 5 over 12. So what is the value of xy? Xy matrix answer comes out to be -5 by 11 and 12 by 11. This way. Now, using matrix method, we are going to solve this system of equation involving 3 variables. So, our supposition of matrices has to be the same. That A matrix equals to what? It consists of coefficient of variables, that is 1, -1, 2, 3, 4, -5, 2, -1, 3. But please ensure that the variables x should come at the first place, y should be below y, and z should be below z. In case some variable is missing, then coefficient of that variable we can use as 0. Next is your variable matrix. 3 variables involved are x, y, z. And then we have the constant matrix, that is 7, -5 and 12. What was the concept we use for matrix method? A into x equals to b. What is x equals to? A inverse into b. What is the inverse of a matrix? A inverse equals to 1 upon value of determinant into adjoint of b. Now, for solving this particular statement, x equal to A inverse into b, we require A inverse, and for that A inverse require first the determinant of A. So let's find the value of determinant of A. What is determinant of a square matrix? It is the sum of elements of a row or a column multiplied by their corresponding cofactors of just one row. I am expanding using the first row only. So element is 1. What is its cofactor? 4, -5, -1, 3. Minus element is -1. And what is sign for the cofactor? Plus, minus, plus. So the sign also minus. That minus will make it plus. And what is the cofactor? Row deleted, column deleted. It is 3, -5, 2, 3. Next is plus, minus, plus. So answer plus element 2 multiplied by its cofactor. For this 2, this particular row deleted, column deleted, it is 3, 4 and 2, -1. Just simplify this. If you simplify this, the answer is going to be 4, which is not equal to 0. Since it is not equal to 0, it's a non-singular matrix and inverse is possible. Now, we have already found the value of determinant, inverse is possible, let's find adjoint of A. Now, what is adjoint of A? As discussed earlier, adjoint of a matrix is the transpose, never forget the sign of transpose, of what? Cofactor matrix. So, I am putting sign of determinant first here, those 9 determinant. Now, let's put the sign plus, minus, minus, plus, minus, this plus, then minus sign for this. Now I put up the value of the cofactors. For this, the same method. For this particular element, row deleted, column deleted is 4 element answer. 4 minus 5 minus 1, 3. You just complete this particular exercise, but always be cautious. When you do the calculation, it has to be not directly orally. It is going to be 3 4s are 12 minus, what's it? Minus minus plus, that is the 5, somehow like this. Once you have found these cofactors, always take the transpose. For convenience, I have found it directly here. So adjoint of A is coming as, transpose sign is here. It is 1 minus 1 minus 1 minus 3, 11 and 7. I have not yet taken the transpose of it. I'll take transpose of it. The transpose comes out to be, the rows are to be written in form of column. 7 minus 19 minus 11, 1 minus 1 minus 1, minus 3, 11 and 7. I got the value of determinant. I got the value of adjoint. Now what I have to do? I have to find the inverse of this. So for finding the inverse, what is it? So A inverse is equals to 1 upon value of determinant, which was 4, and this particular adjoint, which has come after the transpose, 7 1 minus 3 minus 19 minus 1 11 minus 11 minus 1 and 7. Now, where the finally we have to put this inverse, that is in this. So what is it? X stand for the matrix X, Y, Z equals to A inverse, that is 1 by 4, 7, 1 minus 3, minus 19, minus 1, 11 into your B matrix, which was 7, minus 5 and 12. Never divide this particular matrix by 4. It will make your calculation too difficult. This determinant value has to be kept always outside. So multiplication we are doing of this is to be kept outside. So 1 by 4 is still out. Row multiplied with the column. So what's it? 7 sevens are 49. 1 into minus 5, minus 5, and then sweep to be minus 36. Similarly, second row multiplied by this particular column, that will come here. Third row multiplied by this column will come here, this way. So X, Y, Z equals to 1 by 4 outside. This particular calculation answer comes out to be 8, 4 and 12. So divide by 4, it comes out to be, what is it? 2, 1 and 3. But this is still in the form of matrix. Write answer separately. X equals to 2, Y equal to 1 and Z equals to 3. This is how we got the solution of a matrix. Generally, this particular answer comes in the whole number forms. Okay, that is it.